study most likely this afternoon, and then definitely will give back to you on Monday. So don't worry about that. And homework, I already post in the Blackboard about homework 2. It will due on when?
2 weeks from now on Wednesday.
November 6th.
Next Wednesday.
Yeah.
Well, same pattern we'll have. So next Wednesday. So it's like 2
So
weeks.
then, like
from-
the following Monday
Yes.
is Emeritus.
Yes, yeah. So that's next pattern. You are so smart, Kayla. So that's the pattern. So I will try to grade the homework very soon after Wednesday. So I'll give back to you on Friday. Then we'll have an exam on the Monday in the next week. Okay, the exam 2 cover chapter 8, 10, and most important, this chapter 13. Okay, today's class I think is very important because we will begin the model journey of this chapter. EOQ model. We have discussed, okay, to use this basic EOQ model, we need to satisfy several assumptions. Some assumptions are pretty easy to satisfy. For example, no quality discounts or receiving a single delivery. But some assumptions are pretty strong. I mean, in reality, it's really hard to satisfy. Like, you have a perfect demand forecast. You have constant demand, very constant. Your lead time is fixed. But if your situation, you think about your forecast is pretty good, your demand is pretty stable, your lead time is also very stable, then you can use the EOQ model. You don't need to like 100% satisfy. If you're 100% satisfied, then probably you can never use this model. Okay, this picture, we have to make sure everybody here understand this picture before we can move further, talk about formula. So this picture show the time horizon versus your inventory quantity. So the x-axis here is very obvious time, right? Day 1, day 2, day 3, day 4, day 6, something like that. And the y-axis here is the quantity on hand. That means your inventory. How many items you have on hand? Remember, we only consider one product, so we don't worry about, okay, we have multiple products, one product. So the EOQ model, our decision is to make a decision of how many we want to order this Q. That's our decision variable. That's like X, you think about, so you solve the equation. That's the decision variable. We want to solve, okay, which Q can optimize our management. What does this mean, optimize our management? Is by minimize our costs, right? That's optimization. So that's our decision variable Q. Okay, then you see this graph, right? At the beginning is Q. So that means when you order Q, right, you don't have any on-hand inventory. We'll explain why very soon. So when you order Q, let's say Q is 100 units, right? You order 100 units, you receive 100 units. Okay, then your inventory reach the maximum value is 100. And then every day, customer order the same amount. And so your inventory keep decreasing until it's reached 0 again. You order again, this Q, reach 0 again, order again Q. Okay. So this straight line is the inventory line. First question, why? We understand, right? Q definitely decrease because the customer come to buy stuff from us. Why is the straight line, like from 100 to 0? Why is the straight line? It's not like curve, decreasing by curve. Why is a straight line? Anybody know that?
Probably constant.
What's constant?
The rate.
The rate of demand, right? Because we have the assumption the demand is constant. That means if you measure every hour, every day, every week, we have the same demand rates. So the slope is nothing but the demand rates, like per day, like how many you sell per day. That's the reason why this is a straight line. If you see some other model, if you don't have this assumption or you don't satisfy this assumption, it should decrease, but most likely it's by curve, right? Up, down, something like that, right? But that's the reason. The second question, okay, you can see here is the lead time. For example, let's exactly 1 week, 7 days, right? We consume all the Q, 100 quantity, right? Now we place order on Friday. And then we don't know what exact 2 days we receive the order. What's the assumption we have about lead time? Anybody remember? What is the assumption we have for the lead time for EOQ?
It's fixed.
It's fixed, right? So that's related to the next question. Can we make sure the time when we receive the order, we have zero on-hand inventory? Can we make sure that? For the EOQ, can we make sure that? 100% sure? Are you confident? Not confident? Well, this graph shows that, so they're very confident, right? The exact zero, you receive the order. Exact zero, you receive the order. First question is that, we can ask further. Do you think this is optimal? Do you want to receive order when you still have something on hand? No, right? That means you have actual holding costs. Do you want to receive order when your inventory is negative, which means you already lose a lot of customer sales? Don't, right? You definitely know that, okay, that is optimal. When we receive the order, our inventory immediately already gets zero. When the last customer just come, and then we have the order come, right? That's the perfect situation. So that's easy to understand. But the problem is that can we reach this optimal scenario every time? Is that because we are lucky? No? But why? Why we can, this is true. Well, first, definitely, this is true. If under the EOQ model, every time when we receive the inventory, when you receive the order, we have zero inventory. That's perfect. We like that, right? So why? My question is why? How can this happen? It's possible? Related to my last question, the lead time, right? Lead time is fixed.
Well, the way you could do it is if it was a pre-order, the customer ordered ahead of time and you knew exactly when you had to deliver the order.
Yes.
Then you can figure that out.
Yes. Let's do a very, very simple example. Okay. So, your demand rate is 10 units per day, right? Your lead time, LT, lead time is 2 days. Tell me, this reorder point, when you will place the order again, in which quantity? You check your on-hand inventory, right? You have the database, you have the IT infrastructure, you know that. You could, every minute you know how many inventory you have on hand. Then tell me, in which point you will place the order?
8 days.
8 days?
8 days, 10 units a day. Lead time's 2 days. 100 units.
Yes, how many units?
You said 100 units, right?
No. This has nothing to do with the quantity you order. My question is when you place order. When you place order, it really depends on this reorder point, which is your on-hand inventory level. My question is okay, which on-hand inventory level will trigger your action to reorder? So like if somebody say, 50 units, then we reorder. Somebody say we wait until 10 units, we reorder. My question is here, given this simple information, what is the quantity we reorder again?
20.
8 units?
You got 10 units per, 10 units, not per day, no, I'm sorry. Yeah,
20 units?
20 units, right? Yeah. How did that? It's lead time times D, right? 20 units. And under EOQ, we know the demand is constant. We know lead time is fixed. So that means every time we place order, when we have 20 units, we have zero risk. Well, we are 100% sure this order will receive 2 days, the same time later. And we know that at that time, our inventory is zero. Clear? So this is not true for in reality. We'll discuss some complex model later. But under the assumption of EOQ, that's the graph of inventory. Questions, comments? I hope everybody understand this picture before we can move further. So EOQ model, you can see the beautiful for picture, you obviously, right? Every time we reach zero when we receive the order. That's the best we can get. Right? We know the exact quantity. And that is a straight line. But now still the last question we have not answered is Q. What is the optimal Q? Okay. We understand under the EOQ, the graph shows like that. But what is optimal value of Q? to get the optimal value of Q, our goal is to minimize our total cost. In fact, in reality, the total cost function can be pretty complex. I deal with total cost function very boring for more than 10 years for my different papers, right? It's really depends on your model. But even in academic paper, it's still a simplified situation compared to the real situation in industry. When I work for industry, that's okay. We not really use mathematical model. We use some mathematical model, but it's more like simulation, right? Even in the academic journal, it's much more complex than this one. But let's begin with the simplest estimation of total cost. Only two components, holding cost and ordering cost. The annual holding cost is calculated this way. Q divided by 2 times H. Now I want to ask you guys, Q divided by 2 times H. Why this is holding cost?
What does H stand for?
H is the holding cost per unit per year. It's here, right? Holding cost per unit per year. That means if you hold one iPhone in warehouse for 1 year, what is the cost? Maintenance cost, cleaning cost, security cost, blah blah. That's holding cost per unit per year. Okay. Well, one thing you think about is you come to university, you come to any university, critical thinking is the skill we want student, or you also want yourself to get. Well, that means I don't want you guys just accept the knowledge, accept the formula from the textbook. Or sometimes you have to accept because it's too complex, right? But this one, I believe you can figure out that why holding cost is Q over 2 times H. Look at this graph. Why holding cost is Q over 2 times H? How do you calculate holding cost? Any question? I have asked several questions, but you can think about it. Any answer for any question, like, for example, why is, do you think it makes sense? Q over 2 times H makes sense for the holding cost? Why this makes sense for you? No?
Simple.
The circle?
It's simple.
It's simple. Okay. Yeah, you like simple formula. I understand. As simple doesn't mean right. For example, I can change to Q times H. It's wrong. I can tell you directly. Holding cost, if you say Q times H, is wrong. But why is Q over 2 times H is correct?
The usage rate.
Usage rate is constant, right? Yeah, that's related. Joshua, it's related, but it's not the oldest reasons. Okay, to explain that, think about how we calculate the holding cost. The theoretical way to calculate holding cost is pretty silly. It's very silly, in fact. How we calculate our holding cost is that every day, right? We calculate the holding cost every day, right? We estimate together 365 days. That's our annual holding cost. Makes sense, right? Because otherwise, how can you calculate the holding cost for 1 year, right? It's definitely you add for every day. Then, what is our holding cost every day? Only one product. That's times 365, that's the annual. Is how many units you have in this particular day, like this Friday, right? Times the holding cost per units per day, right? That's pretty easy, but you have to do that every day, right? You check we have 10 units on hand today. Okay, each unit is what is the holding cost? $1 per day. That's $10 this day. You add 365 days. That's your annual holding cost. Theoretically speaking, that's the correct way. But you can see it's pretty silly because it have to calculate every day. Then we think about how can I handle that? You think about average, right? Instead of we calculate, we count how many units we have every day. We can count the every units we have for the whole year. It's the same idea, right? We don't have to know exactly what units you have, how many you have every day. If we know the average 10 units, I use 10 times H. That's your annual holding cost. Agree? Agree with me? If the average is 10 units, you just use 10 units times H. That's your annual holding cost. Do you guys agree or some concern? So average capture everything, right? If you can guess the average. Okay, sometimes it's not easy to guess average. But that is related to what Joshua just mentioned, right? So we have the Q is our maximum level of on-hand inventory, right? It's going straight down to 0 with the constant rates. Then you can see this is a triangle, right? To calculate the area of triangle, how do you do that?
Based on type of
Yeah. In fact, for this one, we just calculate the heights, right? It's Q divided by 2, right? We know for sure, right? Because we spend the same time from Q to this middle point, the same time from this middle point to 0, right? So the average is very straightforward, Q divided by 2. Then times H is our annual holding cost. Clear? Right? But again, this is just for EOQ. Well, like we said, okay, if this assumption is not satisfied, we can't use this simple formula to estimate the average inventory, right? Because maybe it's from 10 to 0, but most time you have 6, and then it's not 5. Right? So that's why it's Q over 2 times H. Okay, the second thing I think is easy for you guys to understand, but I will still ask you guys. Annual ordering cost, they give this formula to us. D, which is the annual demand, right? 1,000 units per year, that's our annual demand. Divided by Q, remember Q is the order quantity. Every time you order 100. Times S, which is the per order cost. When you place one order, you spend like $300, something like that. Why this is the annual ordering cost? First, let's look at this one. What does D over Q represent? D is your annual demand, Q is your order quantity. You can think about some example. For example, your annual demand is 1,000. Your order quantity every time is 100. Then it's 1,000 divided by 100 equal to what?
10.
10. What does this 10 mean? 1,000 for the whole year. Every time you order 100, the ratio is 10. What does this 10 mean?
You're gonna order 10 times.
Yes, very good. Alan? So that's the numbers of order you place for the whole year, right? How many order you place? That's 10, our example. Then it's very straightforward. S is the every time you place order, what is the cost? So that's the annual ordering cost you have, right? The time of orders times per time cost. That is very good. Then we know, okay, that is a good estimation for the total cost. Everybody still follow that? Okay, good. Okay. So Q is the order quantity. Q is our decision variable. We don't know Q. We want to solve this Q, right? But H, S, D, we should know that. Like demand, if you have perfect forecast, you know the D. S and H mentioned you have to estimate the holding cost and ordering cost pretty accurately. Now the total cost curve is a U shape. This is the dashed line. The holding cost is straight line because holding cost is the linear function of Q, right? So Q is the x-axis. So linear function of Q, so it's a straight line. And the ordering cost is a decreasing function with Q. Now this is easy to understand. If you order more and more, that means you order less and less times. That means the order cost go decreasing, right? But add them together, that's the middle points, make the total cost minimize. That's our goal, to find what is the Q to reach this optimization point. Okay. This is the formula you want to remember. I definitely suggest everybody write down this formula. Optimal Q is equal to 2ds divided by h. Take the square root. Now I don't require you guys to explain this to me why we got that, because it's related to the calculus. So still, for some students really interested in the math, I want to give a simple explanation why we got this formula. So you think about it, we have a total cost function is Q divided by 2 times H plus D divided by Q times S, right? That's our total cost function, right? Total cost function is a function of Q. Then we want to find a Q to minimize this total cost function, to minimize this function. You remember in calculus, we have learned something, say we take the first derivative of a function, set the first derivative equal to 0, and solve this equation. And this equation will tell us the optimization points. Do you guys have some little impression about that? I believe your advanced calculator have teach you. So basically speaking, you take the derivative of this function, right? Take the derivative and set equal to 0. And you solve this equation, you will get this solution. Okay, that is, take the derivative is h over 2 minus ds divided by q squared equal to 0. You solve this equation for q, then you will get this one. Okay, you don't need to really understand this, but I just want to explain for some students if you are interested, right? Okay. But everybody should remember that, okay, by doing the calculus, that by take the first derivative equal to 0, then we solve this optimal Q. Well, for math, we understand, we are very sure this is optimal points. We are very confident. After you finish copying the formula, you don't need to this one. Wow. This one is really important. Any questions before we move to the formula? Oh, sorry, example. Any questions for the EOQ? It's clear? Because that's different with forecast, right? Forecast is some kind of hard, but this is different. This has nothing to do with statistics. Instead, it's related to calculus. So that's why we require you guys to have statistics and also calculate before moving forward. Question, comments? Good? Everybody's good? Let's go. I'll give you a lot of time on this example. Don't worry about it, the time. A local distributor for a national tile company expects to sell about 9,600 steel-belted radial tiles of a certain size and trend design next year. So, tell me, 9,600, which location correspond to this 9,600? D is a demand. Very good, Joseph. So this is annual demand. So we don't need to worry about the converts daily or monthly to annual. This is already the annual demand, right? Next year. Annual carrying cost is $4 per tile, and the ordering cost is $75. Which location is corresponding to this $4? 4. Which one? Which notation? H. Again, Joseph is very sharp. It's the holding cost. It's the same. Carrying cost is the same as holding cost. What about 75? Now everybody should understand. Which one corresponds to 75? Yes, Angela. Again, very smart. 75 is the ordering cost. Right? You can see that it's pretty straightforward. We have all the information we need. Right? The distributor operates 288 days a year. Well, that means they definitely have weekend or holiday. So they only operate 288 days per year. Part A, what is EOQ? EOQ, economic order quantity, is Q0. Part A is that you just plug in the number, you get Q0. That's part A. Part B, okay, you have to think about it. After you get EOQ, after you solve this Q, how many times per year to order? Part C, what is the length of an order cycle? What does this mean? That how many days you place the order? Right? Place order every 10 days? Or every 20 days? Or every 5 days? That's part C question. Part D, what is the total annual cost if you use EOQ? Well, how do you do part D? It's here. Right? The total cost function. After you solve the Q from part A, you plug in into the formula, you calculate total cost. That's part A. I'll give you guys 20 minutes. Now, try to do this problem. First EOQ, I hope everybody can handle part A. Pretty straightforward.
So EOQ is like Q0?
Yes, EOQ is represents economical order quantity. What that is economical order quantity? It's optimal order quantity, right? This is optimal order quantity. Okay. Many students have already solved the part A. And what is part? How to get part B? How many times we need to order in this 1 year? Yes, the same again. Double check your results. Remember the square roots cover the denominator too.
Yeah.
I think
Okay, have you taken the square roots?
that is something.
Square roots.
Yeah. But when dividing that. What is the EMC? What is the, what is it used for?
It probably is.
No? Formula is correct. No, it's 9,600. That's a reason.
Yeah, that's
600. For which one?
oh, I know.
I see most of you guys have finished part A. I want to see anybody finish part B. Anybody? Part B. Finish part B?
Would be.
Joseph, you really understand the inventory, right? Comparative forecasting.
Yeah.
Would the B be the D times the LT? Or
Oh,
we
well,
don't need this?
We don't have LT. In fact, you are very, we don't have LT information. Need time. Nobody tell me us in this question. So
That's for this one.
Which one of the
Okay.
yeah.
for
How many you orders? You think about it. You right now pass A Q. Okay, every time you place 600 units, right? You order 600 units, and then for the 1 year, how many order you will have? Every time 600.
9,600 divided by 600.
Your demand, right, divided by the order quantity, right? Right. So
I'm a little lost.
it's total cost. You are jumping to past past 2, right?
The lead time.
Past 2 and 3. And go ahead. Yeah, very good. Figure out. Very good. Smart. See. Still have. Okay. All right. Yeah. You got multiplied by 2. Yeah, 2 times DS.
Like how long does it?
Got that. Very good. B is correct. C. Okay. What is the length of cycle? This question means, okay, how many days you wait for the next order? For example, you place order this Friday, right? And you place the next order next Friday. That means the length is 7 days. Pretty straightforward, right? That's what we want to figure out. Okay, you place this order today. How many days you wait to place another order? If you think about it, how can I feel? Spend some time. Then I'll give you a hint. How many days?
That gives you 18.
Okay, the interval between 2 orders.
You found it.
I did 600.
Very good. Since pass B is not challenging, I can see like half a students have solved pass B without receiving any hint from me. But pass C, in my personal opinion, is the not the hardest, but the more trickiest part in this question. I want to see who can figure out pass C before I give any hint. The length of order cycle means the interval between two orders. If you place order this Friday, you place the next order next Friday. What is the length? 7 days, right? Then we have to figure out, okay, we already know our order quantity, right? Then how many days we need to wait to place another order? We know EOQ, in fact, this interval is fixed. Every time we do the same thing. If it's 10 days, every 10 days we place order. That's how many days? It's a very simple formula to figure out that. It's just a ratio.
The reason why I did what I did to get 18 as well was if you order 16 times per year,
Well, I know that, 236 divided by not by 6, I mean, 9,600.
Who's already in the phone?
but I kind of agree with yours a little bit.
Got the same thing.
Yeah, that's what I did.
I did it one way, you did it another way. We both got the same thing.
So that would be 6,
Okay, wait, hold on. And then two
I want to order.
65 days.
This is mine. This is what I did in this way.
Then why you call me 86,000?
Because no, I said, did you get 18? And then I look over there and he's doing something else, but then he's looking into his calculator.
I'm saying
This
there's
is
16
what
order
I said. And I was
cycles.
like, oh, well, I did it a different way. And he was like,
Very good.
So you're gonna take,
Oh, you guys should talk about both your two methods. But before you guys talk about that, I want to have an internal discussion. Why they come to the same results, which is the correct result.
oh, it is correct? But which one?
Otherwise, this well, like romantic relationship, why you guys have the same? No, right? It's really because both of you use the correct formula. You guys this. But you have to think about, you have to explain to him why you use this formula. You explain to her why you use your formula is correct. But the result is correct. Very good.
Okay, so you know why
I have a question.
you know why I did mine.
So,
Okay, so there's 200, they operate 258. Okay.
do we
In the previous
utilize,
question, we found out how
okay,
many
so
times
if you can
per
do
year.
order cycles, are we using
So now
this
it's what's
288?
the length of the order cycle?
288.
So
So
200.
We are talking
order
about
16 times per
operation.
year.
Operation.
Because you think about operation is that like you sales have you ship out. This is not really sell, this is ship out, right? Ship quantity. So if you think about it, we have a very long holiday, like Christmas, or 7 days holiday.
Days.
It doesn't make any sense we count these 7 days.
I mean, 6
Well, yeah, because you count these 7 days, you order too soon, right? So that's the reason we only count the operation days. Yeah, so that's
So then you're gonna take
And then so I
that
multiplied
600,
by how many days we had.
I mean, I'm sorry, the 16 you're ordering, and divide it by, or it's 288.
Okay, so
I'll
what
give you
is,
18
um,
order cycles.
And then,
got that. Okay. Right. The big
Yeah, 288, which is number of actual days,
Says
divided by
Oh, what
16.
about you? Smart guy?
Gives you 18 exactly.
I said, right? I have bigger forecast. Now, pass D is pretty straightforward. You just plug in the formula, total cost function, you will get which one we have right here? TC, right? Total cost. Q, you already get from part A. Q divided by 2 times H plus.
You can order 16 times per year, 600.
Figure out 600 now? Okay, that's good.
Whatever, right, no, 9,600 divided by 600.
Well, you are very smart, so.
So you're not.
Yeah, that's right. Pass D. Okay, Dino already finished part D. Those copy her people, right? He may be wrong.
it's right there.
I didn't use it. I just did. That's it. Everything's divided by 16. That's what you just got for B for the.
I don't need to press it, right? You already know that. Easy for you? Why George myself? Too easy. I don't come there.
Alright, we got the broadcast.
What are you? What is past B and C? You guys, A and B, B and C.
It's one of those, it's right in front of my face, but I'm just looking at it.
for C, you're finding out, so you've already gotten B. correct?
Yeah.
A is not rank.
So
I
the
don't know
answer is
why.
up
But
here. How many?
okay, the denominator is h. Why you use 4 times that? H is 4 itself.
How many days does it operate?
So then for B, is that
Yeah, that's what I'm
It's up
getting.
there.
Yes.
Like,
Yes, it should be.
You first figure out A and B first.
so that's how many days it operates.
See what
You
wait.
gotta upload it 16 times.
But that, I mean, everything else is right.
How many
Division and then another part of the formula, or is that bottom line right there? Just
No. Bottom line is I say how to guess this Q0 because we take the derivative. But the formula is just the first line. Q over 2 times H plus D over Q times S.
Okay.
That's the total cost function.
That's what I asked you.
That's what I tell you. Person on it.
Are you?
The economic order quantity.
What?
Quantity.
You're
Just a
smart.
fancier way to say
So
it.
figure out 1, 2, 3 by yourself. Or 1, 2. Okay, you are still waiting. That's it. Okay, I think. I mean, from what I saw here, I find okay, you guys surpassed my expectation on this chapter. I don't know why. Maybe you like me better than the previous semester. You hate me more. Then you want to see okay, without you I can still perform so good. But I work around, and most students they figure out pass A and B without any hints I have to give. And there's a lot of students figure out C and D by themselves. Very impressive. And then we have students have different method to figure out pass C. That is more impressive. Okay. So let's do that together. So pass A, Q0. Any volunteer tell me how to guess optimal order quantity? 2 times
9,600.
9,600
Times 75.
times 75 divided by 4. Take a square root. The result equal to 600. Right. That is pretty straightforward. Right. So I believe most of the class figures pass A independently. Okay, B, a little bit tricky, but take some time. Many students have also figured out how to calculate that. How many times? How many orders per year?
9,600 divided by 6.
Kayla?
600, my bad. Sorry.
9,600 divided by 600 equal to 16, right? Why we use this formula? Because 9,600 is your annual demand, right? 600 is every time you receive this order quantity. To satisfy your demand for the whole year, the ratio 16 orders is necessary. Right? We need the exact 16 orders to satisfy our annual demand 9,600. Clear, everyone? Pass C. Pass C at first, I can tell you the correct answer is 18 days. 18 in fact is operating days. Okay, that means every 18 operating days you place order. And ask me very good questions. That's whether we should use 365 or 288. I said you should use 288 days. You think about why. So 288 days is the operation days. But operation days doesn't just include the not just the weekend. It's also a holiday. You don't work, right? You think about Christmas. This facility may close Christmas for the whole week. If you count that as days, you made a mistake. How many days you wait, right? Because you should focus on operating days. Every day you ship them out. You are a distribution center, right? So Christmas 7 days, you have no shipments. So it doesn't matter, right? So that's the reason we should use 288 to decide C. And there's 2 ways to decide, right? Then we have 2 students, they argue a lot on which way is best, but they finally agree. Either way is good, right? Let's introduce Joseph and Kayla. Who wants to go first? Your method.
Mine's quicker.
Okay, it was quick, okay.
So all I did was
Let's write down your name, right? It's Kayla's for theory, right? A big name, right? So it's like Thema or like Gauss. Let's say, okay.
Okay, so like you said, the company operates 288 days. So I took that and divided it by the quantity, which is determined in letter A, and that gives you 18.
Quantity.
16, not 6.
16. That's a B, not A.
Yeah, B.
That's
I'm
B.
sorry.
Yeah. Yeah, you place 16 orders. You have annual operating days 288. So you have, every 18 days you place order. Very good.
Yes.
So let's say Joseph's formula. Okay. Let's say theory again. Theory 2. That's how we write the math paper. Joseph.
What I did was I put the quantity or the demand divided by the quantity, so 9,600 divided by 600, and then I multiplied all that by 288 days.
Wait, you did that. You did 600 divided by 9,600.
I think it was
Oh,
600
yeah.
divided
Yeah.
by, right?
Right. Yeah.
I understand. So it's 600 divided by 9,600 and times
288 days.
288 days. And you get 18 days. Could you explain why you use this formula to calculate the part C?
I did more like I thought that would give me kind of like the what was it like the demand like per day, and then multiplying it by 288 days would tell me how many cycles were in the annual year.
Yeah, in fact, let me try to explain for you. So 600 divided by 9,600, that means the portion, okay, the percentage for each order compared to annual demand, right? 10% or 5%. Then we know that's a percentage of each order. That means one order can last how much, right? Percentage. And then we know for the year we have 288 days times this portion. Then we know for each order how long it can last. So that's the rationale behind this formula. You can see, I agree with what Kayla claimed. Her method is more straightforward. I think most of you guys use her method, right? It's 288 days until you figure out 16 orders, straightforward. But Joseph's source is definitely correct. Nothing wrong. Okay, we can't say theory 1 is better than theory 2. Well, both of them are smart students. Gets the same result. Clear for everyone? So that's I will call that critical thinking. Well, if I teach you guys, okay, most likely I will go to Kayla's method. Well, it's pretty straightforward. But Joseph's one is definitely correct. Right? I encourage you to understand both of these two methods. Though in the exam you only need to get one. Right? It's enough. Okay. Part D. Part D is pretty straightforward. Who want to tell us how to get past D? Anybody? Total cost. Too boring?
So 600 divided by 2,
Okay. 600 Q we get from part A divided by 2 times
4.
4 plus
9,600 divided by 600
times
times 75.
75. What is your final result?
2,400.
2,400, right? Dollars. Okay. Then we solve this problem. You can see my estimation 20 minutes, exact 20 minutes to finish this one, right? Let's see why we need to answer so many tedious questions. Why you think, oh, you have to teach us EOQ, then pass A, enough, right? We get optimal order quantity. That's the most important we need to know. When you think about if you are a manager, okay, I'm your employee, you are my boss. You will treat me very harsh, right? I understand that. But that's not enough. If you I just tell you, okay, oh, Alan, we need to order 600 units per time. Alan is a manager, has no idea about operation management. He say, okay, what's next? When I should place order, right? How many order did you place, right? And if I use your strategy, what's the cost? So that's all the question related to manage your clients. You can't just throw that, oh, that's EOQ. That's the end. No, that's not enough, especially in business, right? Because you have to tell me, like part C, when I should place order. I understand 600, but should I place order every day? No, that's not optimal at all, right? You have to wait 18 days. And then they also need to figure out, okay, then in plan in the future, how many order will you play, right? That's part B. And then finally, you want to show manager or clients, okay, $2,400 is the minimized cost you can get. That's the best you can get. That's the number. You can compare to their previous result. Maybe they have $3,000 per year. Then you told them, I save $600 for these products. Number terms. Right? Otherwise, you just give them an EOQ. You don't get too much credits. You definitely want to show the total cost. It's clear? Okay. Very good. That's the end of today's class. Everybody enjoy a great weekend. We'll see you guys next Monday.